And I'm going to share my screen, share my computer. So that. So today is module 9. Chi-square test. What does the chi-square does? It compare two frequency count or 3 or more frequency count. So for example, if you want to compare, if you want to ask a question, is the proportion of females who are left-handed the same as proportion of males who are left-handed? That question can be answered using chi-square test because you are compared to categorical data. Okay, so we are going to take a look at some questions. Through these questions, we will discuss the basic concept, techniques involved in chi-square test. Okay, so we go through the basic. This is module 9. By the way, the due date for module 9 is this coming Friday. Okay. So first question, if we wish to determine whether there is evidence that the proportion of items of interest is the same in group 1 as in group 2, the appropriate test is so A, B, C, D. The correct answer is C. You can use z-test. You can use chi-square test. By the way, this is not x square. This is Greek letter chi-square. Okay. Why answer A is wrong? Because answer A missed chi-square. When you compare two proportions, you have two weapons. One is z-test, the other is chi-square test. We already did z-test for two population proportions. So we are going to use another technique, chi-square, to perform the same test. So this is question 1. Okay. And now we go to question 3. Corporation randomly select 150 salesperson and found that 66% who have never taken a self-improvement course would like such a course. The firm did a similar study 10 years ago in which 60%, a random sample of 160 salespersons, wanted a self-improvement course. The groups are assumed to be independent random sample. Let pi 1 and pi 2 represent the true proportion of workers who would like to attend a self-improvement course in the recent study and the past study, respectively. The question asks you, what is the critical value when test whether population proportion are different at alpha 0.1? So the question asks you, what is the critical value? Okay. Remember in question 1, when you compare two population proportions, you have two different tests. One is the z-test, the other is the chi-square test. Okay, so the answer for question 3 should have two answers based on situation or cases. If you want to use z-test, that is case 1. And if you want to use chi-square test, that is case 2. In case 1, when you want to use z-test, what is the critical value. Okay, so this is alpha 0.1. When you use that test, let's draw a bell-shaped curve. Okay. So 0.1, okay, and the central area is 0.9. If you have alpha 0.1, the central area 0.9, okay, and you can use your calculator, okay, the calculator. You press F, let's open up my calculator. You press F5, F5 distribution. Let me see my calculator. F5 distribution, and then F1 normal distribution. After that, F3 inverse normal. Okay, and then data variable tail, you select central. Okay.
Professor?
Yes.
Your screen isn't shared.
Oh, thank you so much for your reminding. My screen is not shared. Okay. Let me, okay, share screen. Thank you so much.
No worries.
So now, can you see my screen?
Yes.
Okay, thank you. It is Celine, right?
Yes.
Thank you, Celine. Okay. So you press the F5, F1, F3 button. Okay. Area, you select central because you know central area is 0.9, and then you type in 0.9. Alpha is sigma is 1, mu is 0. Sigma is 1, mu is 0. And then you press EXE, you get a critical value. You get a critical value, okay? One is 1.645, the other is negative 1.645. So positive, negative 1.645. So this is the critical value when you use that test. Any questions? But we are saying when you compare two population proportions, you can use not only that test, you can also use chi-square test. If it is a chi-square test, the question is, what is the critical value? Okay, so that is the question we are going to answer in the next example. Because for chi-square test, we have to introduce very basic, the chi-square distribution, degree of freedom, row total, column total, etc. Okay, so we'll answer critical value for chi-square test in the next question. Okay, before I move on, are there any questions? So now we'll take a specific proportion problem, question 4. This question, I will read the question. Do social recommendations increase ad effectiveness? A study of online video viewers compared viewers who arrived at an advertising video for a particular brand by following a social media recommendation link to viewers who arrived at the same video by web browsing. Data were collected on whether the viewer could correctly recall the brand being advertised after seeing the video. The results are given below. Okay, so you have this data. Arriving method, 2 arriving method. One is recommendation, the other is browsing. And then you ask the question, can you correctly recall the brand? The answer is either yes or no. For recommendation method, 412 said yes. 156 said no. For browsing method, 201 said yes. 80 said no. Okay. Any questions about the context? And now we are going to, based on this context, to introduce some basic concepts. One concept is the data given 412, 156, 201, 80, those data we call observed data. Okay, observed data. Based on observed data, you need to calculate expected data. I use capital E, represent expected data. And how do you calculate expected data? You based on the formula. The formula said E equal to raw total. Raw total means you add this raw together. So 412 plus 156, that is the raw total. Okay, raw total times column total. Column total. Column you add 412 with 201, that is column total. And then divided by grand total. Okay, grand total. That is the expected value. So now I'm going to use Excel to calculate this expected value. Okay, so I'm going to use here. There's a space here. You can see both the context. Okay. So original data. So I will put there is yes, no, and two methods: recommendation and browsing. Okay, 412, 156, then I have 201, 80. This is the observed data. How do I calculate expected data E? You need to calculate total, raw total. Okay, you need to add this number with this number. Okay, 412 add 156. You do the same thing for the next row, 201 plus 80. So these two numbers is the raw total. And then you need to do the column total. Add 412 with 201. This is column total. And do the same with all the columns. The last number here we call grand total, for 849 grand total. So any questions on raw total, column total, grand total? So these two numbers I will highlight. Use yellow. This is raw total. These two numbers, column total, I use green. And the grand total, I use maybe purple. Maybe it's not very clear. Maybe just use this green. Okay. So this is raw total, column total, grand total. Once you have this concept, you calculate expected value. So remember this original number is, I will use maybe bold. Those are the observed value. How do you calculate the expected number? I will put the expected number here. There are 4 expected numbers. Okay, so the first expected number equal to raw total 568 times column total 613 divided by grand total 849. And the result would be the expected value for recommendation method under the people who answered yes. I repeat, the result I get here is the expected value for people who use recommendation method and answer the question yes. So expected value is 410. And this expected value corresponding to 412. 412 is the observed value. 410 is the expected value. How do I calculate the expected value? I use row total 568 times column total 613 divided by grand total 849. Okay, any questions? Okay, once you understand this expected value, you do the expected value for 156. What is the expected value for 156? I put the result here equal to row total times column total divided by grand total. Okay, any questions? Enter. And then you repeat yourself. What is the expected value for 201? What is the expected value for 201 equal to row total times column total divided by grand total? Lastly, what is the expected value for 80? Row total times column total divided by grand total. Okay, so these four numbers are called expected value. I copied here, one note here. You see that the same number, except I keep 2 decimal places here. Okay, so any questions about expected number?
Is there a way to find it on the calculator?
Brilliant question. You are ahead of us. The calculator method will be introduced later. Yes, there is a way to use calculator method. You get those expected value from calculator. Okay, any other questions? All right, so this is the expected value. Once you get the expected value, we introduce test statistic chi-square. Chi-square test statistic. What is test statistic? It is use observed value minus expected value, square it, and then divided by expected value. This number is chi-square value. If you add them all, sigma means add them all, it becomes test statistic. Why we need test statistic? Because we want to do the test. We want to compare test statistic with critical value so that we can reach a conclusion to reject H0 or do not reject H0. So this is a new formula, test statistic for chi-square. Okay. So now let's calculate this chi-square value using Excel. Later on, I will use calculator. Okay. So let's do this. So each time you need to do O minus E. Every number is in front of you, okay? So square it divided by E. So equal O observed, 412 is observed, minus expected, 410 is expected. This is O minus E, okay? And then you need to square it, okay? And then divided by E. This result is a chi-square value, not chi-square test. Okay, chi-square value. Then you repeat yourself. for other chi-square values equal observed 156 minus expected 157 squared divided by expected. Again, this is chi-square value. Okay, and then do the chi-square value for this cell equal to observed 201 minus expected 202 squared divided by expected. This is chi-square value. Oops. I have to double check. Equal observed minus expected squared divided by expected. So last thing, chi-square. Oh, by the way, final exam, you have questions ask you, what is the chi-square value? Do not confuse chi-square value with test statistic. Okay, right now, we are doing chi-square value. So chi-square value equal to observed minus expected square divided by expected. Okay, those are chi-square value. So chi-square test statistic, did you see this sigma? You add all these four numbers together, you add all four numbers together, you get chi-square test statistic. Okay. So I'm going to add all these four numbers together equal to this number plus this number plus add all numbers together, you get a test statistic. This is my test statistic, 0.09. Okay, so I'm going to write down here, 0.0946. So this is my test statistic chi-square. Okay. And the next question, once you found test statistic, you have to compare chi-square test statistic with critical value. So what is the critical value? Remember this question, we have critical value for chi-square. We'll answer this question in this question here. Okay. So to answer this question, I have to introduce the degree of freedom for chi-square. By definition, degree of freedom equal to number of rows minus 1 multiplied by number of columns minus 1. Look at original data. This is original data. How many rows in this data? How many? How many rows in this data? The data I highlighted here. 2 rows, thank you, 2. Number of rows equal to 2. Okay, so 2 minus 1. How many columns in original data?
2.
Thank you, 2 minus 1. So degree of freedom equal to 1. Okay, and once you have degree of freedom, you also need the alpha. Alpha usually is given. Okay. Conduct hypothesis, use 0.025 level of significance. This is my alpha. Okay. By the way, the distribution of chi-square similar to F distribution. It is skewed to right. Chi-square distribution skewed to right. When you calculate critical value for chi-square, always use alpha. Do not use half alpha, even though it is a two-tailed test. This is a special situation. In the past, we always distinguish between two-tailed test and one-tailed test. We are saying if you have two-tailed test, use half alpha. If you have one-tailed test, use alpha. But in chi-square test, we don't distinguish one-tail, two-tail. Always use alpha as area. So this little area is alpha. Do not use half alpha. Okay, so this alpha is the area when you use calculator. Okay, so now I'm ready to find the critical value for chi-square. Okay, again, your calculator. Okay. To do that, you press F5. Distribution. Okay. And then F3 chi-square. You have CHI, that is chi-square. And then F3 again, inverse chi-square. I repeat, F5, F3, F3. Okay. After that, data variable. Area, you type in 0.025. Okay. 0.025, that is the area. Degree of freedom is 1. And then you press EXE button. And you get 5.0239. Okay. The critical value is 5.0239. So that is the critical value. Okay, that is the critical value. And any questions so far? And now you compare test statistic with critical value. The test statistic 0.0946, maybe somewhere here is your test statistic. And the critical value is here, 5.023. Okay, so this point is a critical value, 5.0239. And this point is 0.09. Obviously, test statistic is not in the rejection region. So you do not reject H0. Okay, but what is my H0? You go back to here, A, B, C, D. You select H0. So the question said, the question asks you, there are two proportions here. The question is whether there's a difference in two proportions. Whether there's a difference in two proportions. When you see the difference, the H0 is not equal. Right? The H1 is not equal. Okay, so you select the one with not equal, and H0 is equal. By the way, you use pi represent population proportion. So the correct answer is B. H0, two proportion is the same, pi 1 equal to pi 2. H1, two proportions is not the same, pi is not equal to pi 2. Okay, and our conclusion, we do not reject H0, means H0 is correct, means two proportions are the same. Okay, any questions? And now go back to one student asked, is there a computer way, calculator way Yes. Before I start the calculator, I will give you a warning. The calculator method for chi-square test is so far the most difficult one. Most students will go through 3 times using this calculator so that they get the point. How do you use this calculator? To do what? To do chi-square test, specifically to find the test statistic and to find the p-value. Okay, few students can get it the first time you run the calculator, I mean. So be prepared. If you're not comfortable first time, you are totally normal. You need to do second time, third time, fourth time, many times, okay? So I try to go slow. I strongly suggest you pull out your calculator, okay? Follow my steps, okay? Use the data in front of you here. So what we are going to use, we are going to use this data here to do chi-square test, okay? So make sure your calculator is at the home page. Okay, this is your home page. And then you press F3 button. F3 test. And then F3 button again, chi-square test. After that, press F2 button, two-way. So I repeat, to do the chi-square test, you press F3 test, F3 again, chi-square test, and then F2, two-way. After that, you have this computer screen, okay? So you have a chi-square test, and then you have observed matrix A. The original data is observed data. Original data is observed data. So after you see observed matrix A, you press F2 button. You are here. F2 button. Okay. And then you have the dimension. Remember, original data is two rows, two columns. So you need the dimension 2 by 2. If you press F3, you can set up dimension, F3 button. You have a dimension M by N. M equal to 2, N equal to 2. Okay. So you need dimension M equal to 2. Use down arrow key to go to N, typing 2. So dimension M equal to 2, N equal to 2, 2 by 2 matrix. Okay. So after that, you press dimension 2 and then 2. EXE. You have to press EXE to take effect. Okay, and then press EXE again. You get this matrix, 2 by 2 matrix. Any questions? I stop here. And once you have this matrix, you type in the number 412 EXE, 156 EXEK, 201 press EXEK, 80 press EXEK. You type in the numbers. After each number, you press EXE. Okay. So I pause for a moment. Are there any questions? Enter the matrix into the calculator first. So after you enter the matrix, you press exit, EXIT, EXIT twice. Exit 1, exit 2. You press exit twice. Okay. And then you press EXEK. You get the test, let me see. Wow. You get test statistic 0.0946. And you also get a p-value. P-value is 0.7584. So here you get test statistic 0 is here. And you also get a p-value 0.7584. Okay. You get both test statistic and p-value. Okay. So any questions? By the way, the calculator usage, the detailed instructions is presented in the textbook. Remember, my lab have electronic textbook. Take advantage of that. Okay. So we get test statistic and p-value. And how do you get the expected value from calculator? Okay, you need to do this. After you get the p-value and test statistic, you go to exit. You press EXIT, you are here. And then use down arrow key to go to expected matrix. Expected matrix. Okay. And then you press EXE, expected matrix. And then you press F2 button. After that, you go to matrix B. Matrix B is your expected matrix. And then matrix B, and then you press, I lost my expected B. And you get expected value. Matrix B. Okay. So again, detailed steps are presented in the electronic textbook. Okay. So any questions on how do you calculate the test statistic by hand? So we use the Excel, we calculated test statistic. And we also use calculator to calculate test statistic. Okay. So I'm going to verify if the distribution chi-square p-value lower .0946. And now I'm going to show you how do you use calculator to get a p-value. Another method using F5 to get this p-value here. So remember what is the p-value? P-value is the area corresponding to test statistics. Okay, remember where is your test statistic in this diagram? See, this is your test statistic. So what is the p-value? P-value is the area corresponding to test statistic. This shaded area in green is the p-value. And how do you find this p-value? When you have test statistic 0.0946, you do this. You do F5 distribution, F5 distribution, and then F3 chi-square distribution. After that, you do F2 accumulated chi-square. I repeat, F5, F3, F2. And then your calculator said data variable. Lower, you type in 0.0946. That is your lower bound. And then upper bound, you type in 10,000 or any big number, very big number. Degree of freedom, df is 1. And then you press exe. You get 0.7584. Okay, you get this from your calculator. So that is two different methods to get p-value. One method, you need test statistic 0.0946. Once you have this test statistic, you press F5, F3, F2, you get this p-value, 0.7584. The other method to get p-value, you start off with F3, F3, F2. You get p-value in addition to chi-square test statistics. Okay. Any questions? So that is a chi-square test for two proportions. Sometimes you also have questions about three proportions. I'll try to find an example. If not, I can make up one. Here we go. Yes. So question 7. Question 7. This is, we also call contingency table. You have multiple rows, multiple columns. Okay. In this situation, you have three proportions. Okay. The question asks you, the basic question for any test. Question 1, what is test statistic? Question 2, what is p-value? Question 3, what is critical value? Question 4, what is your conclusion? Okay, those are very basic questions will be asked for any hypothesis test. Okay, so let's answer those questions based on the data here. This is the data. Okay. In this data, we call the given data observed data. Okay. In this data, you have 2 rows, 3 columns. Okay. So we'll answer those 4 basic questions. Question 1, what is test statistic? Question 2, what is p-value? Question 3, what is critical value? Question 4, what is your conclusion? Okay, and we are going to use this computer, okay, calculator. All right, so first question, what is chi-square test statistic? To answer that question, of course, you can use by hand, use this method. You calculate the expected value, and then you calculate row total, column total, grand total, okay? And you figure out the chi-square test. But we want to practice the usage of calculator. So I'm going to show you how do you enter 3 proportions into the calculator. So I'm going to return back to my calculator here. This is the very basic model. So to do the chi-square test, Step 1, you press F3 button. F3 test. And then F3 again, chi-square test. So F3, F3, and then F2, two-way. Okay. You can still use matrix A. There are many matrix A, matrix B, matrix C, matrix D. Okay, so let's maybe start all over again. We still use matrix A. Okay, but this time matrix A has 2 rows, 3 columns. Okay, so once you are here, you need to press F2 button to set the matrix A. Okay. And then F3 button asks you to enter how many rows, how many columns. M is a row, N is a column. So this question we have M equal to 2, okay? N equal to 3. We have 2 rows, 3 columns. Okay. So 2 rows, 3 columns, and then you press EXE button. See, you have a 2 row, 3 column matrix. And then you enter the data. Between the data, you use EXE key. So the first data is number 10. After number 10, you press EXE. Okay, the cursor go to the next data. Next data is 30, EXE. And then 50, EXE. 30, EXE. 35, EXE. 45, EXE. See, I entered all 6 numbers in 2 rows, 3 columns. Okay, any questions? So after you enter the number, press EXIT, exit twice. Exit twice. And then press EXE. See what you get? Test statistic and p-value. Okay, so I'm going to write down. After that, I get my test statistic, chi-square equal to 8.735, 8.735, and I also send 5, 1, keep 4 decimal places. I also get a p-value equal to 0.0127. So I get a test statistic, I get a p-value. Okay. And the calculator also gives you degree of freedom is 2. Why? Remember what is the definition of a degree of freedom? Number of rows minus 1 times number of columns minus 1. This example, we have 2 rows, 3 columns. So number of degree of freedom equal to 2. Okay. And the last question, what is the critical value? Okay. To do the critical value, you press F5 distribution, and then F3 chi-square. After that, F3 again, inverse chi-square. And make sure data is variable. Area, type in alpha, see alpha 0.005 If alpha is not given, you use 0.05. And degree of freedom is 2. Okay. Here. Then press EXE. Okay. Oops. Take. So I get 5.99415. Critical value. Critical value. 5.9915. Okay. Any questions? In summary, what we did in this lecture, we did a chi-square test. We answered 4 important questions in any test. Question 1, what is test statistic? Question 2, what is the p-value? Question 3, what is the critical value? Question 4, what is your conclusion? And for this example, if you use p-value method, you compare p-value with alpha. When p-value smaller than alpha, reject H0. So this is our conclusion. Reject because p-value smaller than alpha. Okay, and then what is my H0? It is here. Okay, when you have 3 or more proportions, how do you set up non H0, H1? Okay, so the correct answer is B. H0 said pi1 equal to pi2 equal to pi3. H1, not all pi are equal. Okay. All right, so any questions? Okay, you can always email me about any question you may have, or hold on your question until next Saturday. Next Saturday, we'll do simple multiple regression, okay? After next Saturday, we'll do multiple regression. So anyway, we only have 2 more weeks, 2 more meetings, okay? That's all for today. Thank you so much for your participation. I appreciate your effort. Have a good evening. I look forward to see you on our next meeting.
Thank you so much, Professor. Have a good weekend.
Thank you.